Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve questions from sample paper number 1, the 4th edition of RK Bali navigation book. Let's begin. Question 81. A primary radar operates on the principle of phase comparison, continuous wave transmission, pulse technique. So the answer is pulse technique. The primary radar is going to send radar pulses in the direction of your aircraft. This radar pulses will strike your aircraft and get reflected back at the primary radar. So it uses pulse technique. Continuous wave transmission is used in radio altimeter. Phase comparison is for VOR. Next, factors liable to affect most NDB ADF system performance and reliability include static interference, night effect, absence of failure warning system, static interference, station interference, latitude error, height error, station interference, mountain effect. So the correct combination is option alpha, static interference because of thunderstorms, precipitation, night effect when the D layer in the ionosphere disappears, absence of failure warning system. It doesn't have any failure warning system. So option A. The reason for using different frequencies for transmitting and receiving in the DME system is, now let's say this is your ground. You have the DME ground station, you have aircraft. Now this aircraft is your interrogator. This aircraft is your interrogator. This aircraft is your transponder. This interrogator transmits interrogation pulses in the direction of your DME ground station, your transponder. This interrogation pulses are at a frequency of 1090 megahertz. The DME ground station will wait for 50 microseconds and reply to this interrogation pulses by sending radar pulses in the direction of your aircraft. Now this reply pulses are at a frequency of 1030 megahertz, right? 1030 megahertz. So this is how the DME uses two different frequencies, one for interrogation and another for reply or response. This is done in order to prevent the interrogator in your aircraft to lock onto its own frequencies or any other reflections from the ground surface. So the correct answer is to prevent self-triggering of the receiving equipment by the transmitter. Okay. 84. What is the maximum distance between VOR and DME Takan ground installations if they are to have the same Morse code identifier? So there are three conditions. First, both the aerials are co-located, okay, at same site, are co-located. In this case, so now they will share the same Morse code identifier. When the distance between the aerials of VOR and DME is separated by, the distance is equal to 30 meter or 100 feet in terminal area, in terminal area. And when the distance between them is equal to 600 meter or 2000 feet outside the terminal airspace, outside the terminal airspace. So the correct option here is 600 meter. Okay, 600 meter. The minimum number of satellites required for receiver autonomous integrity monitoring is how many? So remember, you require one satellite. One satellite is required for position in space. Second satellite to have ambiguous position on the earth. Third satellite to have ambiguous position in space. Fourth satellite to obtain a fix in space. Fifth satellite for receiver autonomous integrity monitoring. So the correct answer here is the minimum number of satellites required for RAIN is 5. Okay. Next, what is the first returning sky wave called? The first returning sky wave will be called the critical ray. Next. Okay, so let's consider this is your Earth surface. This is your ionosphere layer. Here is your transmitter, correct? So at a particular angle called critical angle, this radio wave will strike the ionosphere and get refracted and reach the Earth's surface. So the first wave that goes to the ionosphere and comes back to the Earth's surface is called critical wave. And the first time it happens, that angle is called critical critical angle. Okay, and the wave is called critical wave. The distance between the transmitter and the place where the first sky wave returns or the first critical wave returns is called skip distance. Is called skip distance. So next. The critical point is exactly halfway when outbound equals to homebound speeds, nil wind conditions, and crosswind conditions. So critical point is exactly halfway when uh, the atmosphere is calm, nil winds. Okay, no headwind, no crosswind, no tailwind. Next, when tracking a VOR radial inbound, aircraft would be flying a constant heading. Not necessary. You may be flying a VOR radial, but because of crosswind conditions, your aircraft heading may be deviated from your track. A rumline track, a great circle track. So remember, all VOR radials are great circle tracks. A VOT is a test VOR, tracking VOR, terminal VOR. So a VOT is a VOR test facility. Terminal VOR is written like this, TVOR. Next. Aircraft is on a heading of 100 magnetic from a VOR. To make VOR ILS deviation indicator needle centralized with the two flags showing, the following bearing should be selected on the OBS. So aircraft is on a heading of 100 degrees from a VOR. Okay. So let's say this is your VOR station. This is the north datum. So this is a track 100, the reciprocal of which will be track 280. Now, if you're flying a heading of 100 from a VOR, meaning you're tracking a direction of 100 from a VOR, that means you're flying away from this VOR station. You're flying away from this VOR station like this. So there are two ways, two possibilities. You can set your OBS selector 100. In that case, you get a from indication. If you maintain the center line of the radial, your needle will remain in the center. Now, if you want to have or if you want to obtain two indication in the OBS, you are going to set the reciprocal of track 100, which is 280. So OBS set 280, you get a two indication needle center if you remain on the center of this radial. Okay, so the correct answer is you set Charlie 280 degrees. So this ends our lecture. I hope you have understood all the 10 questions I have explained in this video lecture. If you have any doubts or questions, let me know in the comment box of this video. I urge you all to share this channel with your friends who are preparing for the exams. Subscribe to this channel if you haven't yet, and hit the like button if you have liked this video lecture. In my next video lecture, I will solve the next remaining questions. So I hope to see you there.